Hi students, today's our topic is one more questions, important questions in exam point of view in real numbers. We have here first question. Using Euclid division algorithm, find HCF of 408 and 128. So by using this Euclid division lemma, we have to find highest common factor of 408 and 128. Here, Euclid division algorithm is whenever A divided by B, then we have an equation here. A is equal to BQ plus R. Already we will know this equation. It is a division algorithm. Here is called as dividend, and B divide Q quotient, and R is remainder. Dividend is equal to divisor into quotient plus remainder. So now in this class it is named as a Euclid division algorithm. So whenever you divide A by the number B, we will get some quotient Q and as well as R. For example, I am taking 7 by 2. So divide 7 by 2. Then we get simply 7, 2, 3 the 6, 7 minus 6, 1. That means that 7 can be written as 7 is equal to 2 into 3 plus 1. Here 7 is taken as A and here 2 is taken as B, 2 is taken as B, and here it is Q. 3 is taken as Q and 1 is taken as R. That is A is equal to BQ plus R. So by using these type of equations, we have to find the common factor of 408 and 128. So whenever you get the R as 0, then we can say B is the factor of A. So by using this type of equation, we have to find the HCF. So see this how 408 128. So now divide 408 by 128. 128 1 128, 128 is 256, 128 3 is 384. So it will be taken as 3. By counting like that we get 384. Now on subtraction, 8 minus 4, 4. Now we are borrowing 10, 10 minus 8, 2. Now we get here 3, 3 minus 3, 0. Now again divide. It's 24. We're taking 128 as a dividend. So 24 5s are 120, remainder 8. And again 8 and 24. So like this we have to do the same process. 8 3s are 24. 24 minus 24, 0. So wherever you get the 0 as a remainder, and there we can write the factor, that is divisor becomes a HCF. So to do this process, we have to write down equation form. So first of all, this 408 in first division, 408 is equal to, we can write 128 into 3 plus 24. And again from here, 24 is equal to, so 128 is equal to 24 into 5 plus 8. And again this 24 is equal to 8 into 3 plus 0. So wherever you get the 0 as remainder, the divisor 8 can be taken as HCF. So like this you have to do the HCF of the 408 128. Okay. Now the next one, let's take one more simple sum here. 72 and 108. The second sum is same by using the same Euclid division algorithm. Find the HCF of 72 and 108. So here also you have to do the same process. First we take 72 and 108. Now divide 108 by 72. 72 1 to 72. So it's enough. 72 to 144 it becomes excess. So we have to take 72 on the 72 by subtraction 6 in here. And again divide 36 and 72. 36 to the 72. So remainder 0. That's why here 36 is a HCF. So but we have to write the Euclid division algorithm type, that is A is equal to BQ plus R type. So 108 is equal to 72 into 1 plus 36, and again this 72 is equal to 36 into 2 plus 0. Whatever you get, where you have to get the 0, then that divides the 36 is taken as HCF 36. So like this you have to do the finding HCF in the process of Euclidean division algorithm. Okay. Now again, one more important concept here, that is write the decimal form of the given fractions without actual division. Without actual division. So that is also comes under one more question. So here second model is write the decimal form of decimal form of the following numbers without actual division. Without actual division. Okay. Now your first one is 7 by 8. So in this 7 by 8, take denominator 8. Take the factorization of this one. 2 4s are, again 2 2s are, 2 1s are. As we all know this one, then 8 can be written as 2 into 2 into 2. Then 8 is equal to 2 cube. So we can write it as 7 by 2 cube. So to get the decimal, in denominator we have to get the 10 multiples, that is 10 power 1, 10 power 2, 10 power 3, that means like that you have to get. So that's why to get that 10 powers on denominators, so multiply 2 cube by 5 cube. And because we know that 2 into 5, 10. So whenever you get the 10 powers on denominator, we'll get easily the decimal fraction of the full given fraction or given number. So that's why here we can write 7 into 5 cube is 5 into 5 into 5 divided by 243 into 5 cube. We can make it as 2 into 5 whole cube. Then 7 into 5 into 5 into 5, 125. 125 by 2 5 is 10 cube. And 125 7s are, we can write it as 35, 1470, 875. 875 by 1000. Simply we can write it as 0.875. So without actual division, we can make it as like this. So first I have to do the prime factorization of 8, then we get it as the 2 cube. So whenever you get the 2 cube, multiply it by 5 cube. Why 2 into 5 is 10 we know. So whenever you get the 10 powers on denominator, it is easily we can say what? Decimal number. So 7 into 125 you got 875, 10 cube is 1000. So by removing these 3 zeros, we get the decimal point on after these 3 places, 8, 5, 7, 8. So that is 0.875. So like this we have to do the decimal form without actual division. The next 15 by 16. The next number is 15 by 16. The next number is 15 by 16. Now here also take the prime factorization of 16, 2 8s, 2 4s, 2 2s, 2 1s. That's why here 16 is equal to 1, 2, 3, 4. 2 is in 4 times. That's why we can write 2 power 4. So that's it. We can write 10 by 2 power 4. Here again we need to multiply it by what? 5 power 4. 5 power 4 by 5 power 4. Why? Because we have here 2 power 4. So to get here 10 multiples we need 5's in 4 times. So we can write it as 15 into 5 power 4 is 5 into 5, 5 into 5 divided by 2 into 5, that is simply we can write 2 into 5 whole power 4. So 15 into 5, 5 is 25, 5 is 25, 25, 25 is 625, 625 by 10 power 4. Then next 625 into 50, that is 75, get into the 30, 37, 90 plus the 93, that is 9375 by 10 power 4 means here 10 into 10 into 10, that is 10,000. So remove these 4 zeros, we can get simply 0.9375. So like this we get the decimal form without actual division. So again, one more simple sum like this. (46 by 2 cube into 5 square). So here we can write 46 by, here already we have 2 cube, 2 power 3. So to get 10 multiples or 10 powers, here we need one more 5. Why? Because here we have 2 power 3. To get here 5 power 3, it should be multiplied by what? 5. So that's why 46 into 5 by 2 cube into 5 power 2 into 5 power 1, that is simply 5 power 3. So we can write it as 5 6 is 30, that is 230 by 10 cube, that is 230 by 1000. So we can write it as 0.230. So like that we get the decimal form without actual division. And next model, without actually performing division, state whether the following decimal numbers will have terminating decimal or non-terminating decimal. So here, without performing actual division, state whether the following rational numbers will have a terminal decimal, or non-terminating repeating decimal, So in that one, first sum is 13 by 3125. So here mainly you have to observe the denominator. The denominator is in the form of 24m into 5/n, or only 24m, or only 5/n. So among these three forms, if any one of them is exist, we can say that the given fraction must be terminal decimal. It has a terminal decimal. Okay. So now we have 3125. To do this one again, we have to do the prime fraction. So 3125, take the denominator, and by taking prime factorization, it going by which table? Pi table. Why? Because by divisible table, on first unit we have what? In first place we have 5. In each place we have 5. So it must be divisible by the 5. So divide it. 5 6 are 30. 12. Balance 12. 5 2 are 10. Again balance 25. 5 5 are 20. And again 5 table. 5 1 are 5. 12 balance. 5 2 are 10. 25 balance. 5 5. Again 5 table. 5 2 are 10. 5 5 are 25. Again 5 5 are. The last is 5 5 are. And we can write 3125 as 1 2 3 4 4 5s. 4 5s. That is 5 to the power of 4. And hence 13 by, we can write 5 to the power of 4. Therefore denominator is in the form of 5 to the power of 4. Hence the given number has terminating decimal. So like this, we have to check up whether the given fraction has terminating decimal or not. Okay, and one more sum. So I think you note down the question. So now here 64 by 455. So here again take the denominator 455 divided by again 5 table. 5 9s are 5 1s are. Okay. And again it's not going by 5 table. So go to the 7. 7 1s are 7. 7 3s are. So simply we got 13, which is a prime number. 13 1s are. So that's why here 455 is equal to 5 into 7 into 13. So the fraction becomes 64 by 5 into 7 into 13. Here denominator is not in the form of 2 power m into 5 power n. So that the given number has what? Non-terminating repeating decimal. So like this we have to do the sums. Okay.